My name's Jason. I'm a product manager on Google Cloud Platform. And as you can see today, we're going to be talking about building serverless applications with Google Cloud Functions. Okay, before we do that, we might need to just describe what this word, this weird word serverless that we see popping up all over the place actually means. And you might think that it means no servers, right? Well, kind of. It could mean any one or all of these things. So no need to manage servers, no need to even think about servers. There's a provisioning argument. Maybe it's about what you pay for. Maybe it's not about billing. Maybe it's about developer experience or the unit of deployment, etc. For the purpose of today, I'm just going to narrow that scope. So we're going to talk about these four things. Serverless, by definition of something that you don't even need to think about servers. You pay only for what you use. It's event-oriented, and you deploy functions and not apps. Okay, what does that really mean? In order to answer that question, I'm going to tell a little story. This is Tony. And Tony has an app, and he's going to run his app on a virtual machine. And so he launches the app, and the app gets some traffic, and his virtual machine is humming along nicely. And then his app gets more popular, and he gets more traffic. And now he can't fit on a single virtual machine, but that's cool. He just gets a second virtual machine. And the extra traffic that couldn't fit on the first one flows over to the second one. Now, if he's got some sort of load balancing ahead of this, it probably looks more something like this, and that's fine. Sweet. Okay, but there's a problem with this. And it's these grey boxes. This means he's over-provisioned. So he's bought and paid for capacity that he's not using. And that's costing him money. Okay, let's see if we can do better. I'm going to start with a virtual machine, but this time we're not going to deploy an application into that virtual machine. We're just going to deploy a container. And then when that container exhausts its resources, I deploy another container, and so on, and so on, and so on. And then, if I'm load balancing, maybe it looks something like that. So that looks good. But then, what if I need one more? Well, I need a whole new virtual machine. So we're kind of back to square one. We still have an over-provisioning problem. I'm still provisioning capacity that I'm not using, and that's costing me money. Okay, let's try again. What if we just removed the server? Now, when he wants to add a new container, he just adds a new container. Sweet. We still do have some waste here, though. You can see there's still a bunch of grey boxes there. So that's still somewhat over-provisioned and still costing money. What if we were to shrink this unit of compute? Rather than deploying a VM image or a container, what if we made it as small as possible? So each little unit is going to have its own amount of capacity, and so the amount that we're over-provisioning is even less. You're still going to have a little bit. You're not going to be able to get rid of it entirely, but this is a much better place to be. And so you end up in this world where you have independent units of compute, independent functions that scale independently, and the amount of over-provisioning is as low as it can be. They scale independently, they're isolated from one another, they're stateless, and they more closely match the traffic pattern. So some functions will execute frequently, some functions not so much. Sweet. Okay. So that's, broadly speaking, a view of computing that's serverless and why, and what that means and why it's important. But how would you use this, and why does this matter to you? So just hold that thought, and I'm going to switch gears and talk about some use cases. Imagine you're building a booking system, and I apologize that this is a somewhat dry and boring example, but it'll serve the purpose. You have some application, some bit of compute that's accepting data. Maybe it's accepting orders. And you want to write those orders to some back-end storage system. In this case, I'm choosing cloud storage as the example. And so that's really the guts of your application. You just take orders and write them to storage. Now you have a new requirement. Maybe you want to do some indexing or some processing of this order before it goes to storage. And so you implement in code some indexing or some library that does this work for you. But maybe that library or that code that you've written depends on a database. So it needs to write out to a database or an index. And maybe it needs some special firewall rules to do that. And probably it needs some sort of special authentication. So that's okay. You put all of that into your application and it looks good. Meanwhile, elsewhere, you have another application, completely separate, that's taking some other data. But it needs to do something similar. This time, maybe it's taking invoices and it's writing them to storage. And then maybe you also need to index that data as well. And you want to reuse some of this code that you've written over in the orders side. So now again, you need the same database, network, and authentication configuration that you had previously. And that's fine, that will work, and that happens routinely. But this might be a problem. You've duplicated this configuration and these settings and this authentication in two different places, not to mention duplicating the code. So what does that mean for things like security, things like deployment? If you change this library, do you have to deploy both versions of your application simultaneously? Let's see if we can improve this. So same application, two different sides of it, invoices and orders. This time we're going to implement a separate API. And the applications are going to call that API rather than writing directly to storage. And that API is going to write the file to storage, and it's going to do all the indexing and have those dependencies. This is classically what we might term, in a very simplistic way, a microservices approach, where you separate logic into services rather than baking it into the application. And this is totally fine, great architecture, works well, Tony loves it. There is one small challenge with this, and that is that you have now, previously you'll recall, we were writing from the compute to storage directly. And the storage, let's say, was a managed service, like cloud storage. So it had SLAs and it had all sorts of uptime guarantees. And now we've created our own API that we have to scale ourselves and have to manage ourselves. And so we've introduced a point of failure here. It's not terrible, and there's many ways to mitigate that. But you now do have to think about, how do I deal with that failure? How does the application deal with the failure to index the data? What does it do? So we might be able to do one step better. Same application. This time, I'm going to go back to what I had before. I'm writing directly to storage. What if the storage system itself was aware of that write, and it could emit an event? So when the write occurred, when the mutation in storage occurred, it would emit an event. And then I could attach code to that event. And that code would have the dependencies. So in this model, I've solved sort of two problems in one. I've solved the original problem of duplication of configuration and code. And I've also solved the problem of not depending on a managed service and the reliability challenges that might present. So it looks good, right? Well, there is one more issue here. Those two applications were pretty heavyweight, and they required virtual machines under a lot of load. But this one little piece that I've pulled out doesn't get called all the time, or maybe it doesn't need many resources. So now I'm back to this over-provisioning situation. If only I had a smaller unit of compute that I could use in place of that. And the good news is that we do. Sweet. So Google Cloud Functions is that lightweight, small unit of compute. It's a serverless environment to build and connect cloud services with code. The characteristics of Cloud Functions are this. You don't need to even think about servers. You pay only for what you use. It is event-oriented, and you deploy in units of functions, not apps. And you'll recall that this is where we started in our definition. Okay, pretty simple diagram, but just to give a sense of what that looks like. Your cloud environment will emit events, as I mentioned. Mutation on a storage bucket might be an event. Mutation on a database might be an event. Also, external services will emit events. Typically, this is materialized as a webhook callback or something like that, so a commit to GitHub, and you can configure that to call you back with a webhook over HTTP. Your function will come to life, respond to that event, and then from within the function, you can do anything that you can do in a normal computing environment. You can call an API, you can write back to the database, you can call an external API. In Cloud Functions within Google, we have two flavors. An HTTP function is a function you deploy with an HTTP trigger and will give you back immediately a URL with a TLS certificate, so it's secure, and you can curl that straight away. That would be for synchronous use cases. The webhook callback will work out of the box for this. The second flavor is the background function. This is where it happens asynchronously. There's an event bus in between, typically Cloud PubSub. This is where you don't need to know the outcome of the function in real time. You're happy for it to be processed in the background. And typically, this will be as a result of an event being emitted from a cloud service. So let's have a look at each of these in a little bit more detail. HTTP. This is the simplest hello world HTTP function you can imagine. We give you an HTTP request and response object. This is in Node. Anyone familiar with Node? The request and response is literally an Express.js request and response. And so if you've ever used Express.js, then you know how to do this. A couple of things to point out, I just mentioned. It's just a regular request response, and then you have the full access to the response object. You don't need to do any sort of crazy translations on the way in or the way out. It's just regular old HTTP. This is what a deploy might look like for that from the command line. We also have a web UI, which I'll show you in a little while. You just deploy the function. You give it a stage bucket, which is where we store your deployment while we're building the function. And then you just say it's a trigger HTTP, and we'll give you back a URL. Background functions. Pretty similar. The only difference here is instead of a request and response, we give you an event, which is the event that was emitted from the cloud service, database mutation, storage mutation, etc. And we give you a callback. The callback is because in runtime environments like Node, everything is asynchronous. You might be doing some work asynchronously, and you need to tell us when your function is done, and so you call the callback. If you don't like using callbacks, that's cool. You can return a promise. In fact, you can just return a discrete value, and we'll treat it as a promise. Again, for the people in the audience familiar with Node and JavaScript, this is particularly useful if you're using a third-party library that's going to return a promise. You don't have to do any kind of black magic, you just return what they gave you. And a couple of examples of deploying background functions. So one here is triggering off a cloud storage bucket, the other is triggering off a cloud PubSub topic. Dependencies. It would be unusual, I think, for you to write a bit of code that has no dependencies on any other modules or any other libraries. Typically, you will depend on numerous libraries of your own or typically third-party libraries. In a Node.js environment, they are expressed in a manifest file called a package.json. You declare your dependencies in there, and then there's a tool called npm, Node Package Manager, that will resolve those dependencies, download all the files, and package up your app. That means that you can do something like this. You can require this external dependency in your code, and typically you would declare it like this in your package.json. So when you deploy your cloud function, we will actually run npm install for you. So you don't have to resolve those dependencies and zip them up into a big fat zip and send them to us. You just send us your source code and your manifest, and we'll handle the rest. And this is what the deploy command looks like if you're using a manifest file. It's the same as it was before, so nothing changes. We just suck that up and run npm install in the cloud. logging and monitoring. So from your Cloud function, you just write a console.log command as you would do normally, as you would do anywhere else. We will capture that and write it to stack driver logging. From stack driver logging, you can do a bunch of interesting things. You can pipe those logs to BigQuery. You can set up a filter to pipe those logs to a Cloud Pub subtopic and have another function execute in response to that. If you have an uncaught exception in your code, that will get sent to stack driver errors. From there, you can set up alerts to tell you that something's gone unusually wrong that we didn't expect with the function. And all of this is available through CLI, UI, and API. The monitoring, we report the essential telemetry that you need, how many times your function is being invoked, how long it ran for, and how much memory did it use. Okay, what does the environment look like that we run in? This comes up particularly for those who might be running any native libraries. And by native, I mean code that needs to be compiled against the underlying operating system. So Cloud Functions run in an open environment, meaning that we just have a vanilla flavor of Debian Linux. We have a vanilla flavor of Node.js. We pre-install ImageMagick just because that's a very commonly used native library. We give you a local disk at /tmp. Within the environment, you're automatically authenticated against other Google services. So you don't have to bundle in any authentication tokens or consider how you authenticate your function against other services in your project. It's automatically done for you. And the last point is about the compilation. Some node modules will have a native component, and when you run npm install, it's going to compile that native code. If you run npm install and it compiles native code on your Mac laptop, and then you deploy to a non-Mac environment, you might have a bad day. So the advantage of having npm install run for you is that you just have to name the dependency. We will run npm install, we will run the compilation step, and by definition it's going to run on the same environment that we're going to execute on, so you don't run into these crazy incompatibilities. If the node module you're using doesn't pre-package a compilation step, and it depends on some library that is not part of the node module, 9 times out of 10 you can go and download the pre-compiled Debian version of that library. And because it's just a standard Debian environment, that should work. If you really, really, really have to compile your own library onto the image, onto the same image, then you don't get this image from us. You just go get it from the internet. Okay, local development. So this is great. I've got this environment, I'm writing my functions, I'm deploying them, I'm executing them, but it's a little slow in the sense that I have to go through the whole deploy process every time I want to make a change. It'd be great if we gave you a local emulation environment so that you can build and test and iterate and debug your functions locally before you deploy them. So this is available today. Just npm install the emulator. It runs a simulated environment of the cloud environment for your cloud functions. It has exactly the same API surface area. So if you wanted to write tooling around how to deploy functions using an API, that tooling will work with the emulator. So you can easily switch between emulator and live code. And you can debug with this. So it has a command to enable the debugger, and then you can attach your favorite IDE to that and step through your JavaScript code. Deployment I already touched on a little bit, but I want to walk you through how this works. So you can deploy inline. We have an inline code editor in the UI, or you can deploy via the command line or via an API. If you're deploying directly from your local file system, we'll zip it up for you without the dependencies, or with the dependencies if you want to send them with us for whichever reason you like. And we'll send it to the API and we'll run the build process from there. If you don't want to deploy directly from your local file system, you can also deploy from your GitHub or Bitbucket repository. This is done using a tool called Cloud Source Repositories. We'll automatically keep in sync your cloud repository with your GitHub repository. And so you're actually deploying from cloud source repos, but it is kept in sync with GitHub, so you don't really have to interact with it. You just commit to Git, or to GitHub rather, and then trigger a deploy, and your cloud source repo will sync. So I want to talk a little bit about what actually happens at deploy time. So you've written your code, let's say you're using the CLI, you've gone gcloud beta functions deploy, and then what happens? So you hit deploy. As I said, we zip it up if it's in the CLI. When it gets to the server, we run npm install. If there are already packages there, then we might just run npm rebuild to capture any native compilation that needs to happen for the platform. We have internally a thing called create version. So what this is doing is saying, okay, we have a new version of this function. I'm going to create a new version so the existing version continues to exist. And before we do anything, I'm going to health check that. I'm going to make sure that that thing is okay. That means that the environment's spun up correctly, the image has been created correctly, the runtime has started correctly. We can't check that your function is going to work, because your function, of course, may have side effects. So we can't invoke your function, but we can go as far as, we can do everything but that to make sure that everything's okay. And if everything's okay, we'll mark the deployment as complete, and then we'll gradually move traffic from the old version to the new version. Okay, so that all sounds great. Now what do I do? One of the use cases that pops up quite a lot, and I've touched on it a few times, is lightweight ETL. So file comes in, hits storage, or comes into the cloud, and you want to do some transformation of it before it goes somewhere else. So one solution to that is have the file hit storage immediately, have storage call a cloud function, and maybe from there you want to write it to a database. Or maybe you want to send it to BigQuery. Or maybe you just want to write back to storage with a mutated version of that file. This comes up in things like image processing, video processing, indexing, like in my earlier example, entity extraction. You might want to send the image to the Vision API to pull the entities out of it, content sanitation and filtering, those sorts of things. Semios is one of the customers we have using cloud functions for this. They're in here because I thought they were a really interesting use case. They have around 150,000 sensors in orchards, tracking things like temperature and pressure, humidity, those sorts of things. And they aggregate all that data in the orchard and send it back to the cloud. And it passes through a cloud function on its way through, and through that cloud function they're doing some filtering before it gets to the database. Another use case we see a lot, and I also alluded to, is microservices and webhooks. So there's a few different flavors of how this might work. One is that the client is calling, typically via HTTP, calling the cloud function directly. So the client is outside of the cloud function is inside the cloud, and they just call it directly. You could think of this as a microservice. The client may also be inside the cloud in this case. API, so similar to a microservice, but it's where the client is calling the cloud function and treating it as an API in the same way that you would if you were to build a website with expose endpoints. The mobile client is calling directly to the cloud function. Webhook, this is the example I gave before, where somebody like a GitHub might be calling you back, or maybe you're sending an SMS using Twilio, and they're going to call you back with a webhook when it's done. So microservices, data ingestion APIs, and callbacks from external services. A good example here is Vroom. Vroom are the largest used car seller on eBay, and they accept data from partners. They have a network of partners. They want to accept data. They're using cloud functions as a data ingestion mechanism, as an API for their partners to call. And the last one I want to talk about today is More of a fun use case, so bots and actions. So this is where some messaging client, some chat client, some voice-enabled device is going to use a cloud function to create a custom command, something to extend the behavior of this tool. So they'll use a cloud function for doing this. Typically, again, enabled over HTTP, messaging bots, things like adding custom actions to Google Assistant and home automation. So the example here is Meetup. They created a custom Slack command. And so when you type this Slack command into their Slack channel, it will fire a cloud function that will create a ticket in Jira. It's part of their way to automate their development processes. This is my own artistic talent being shown. It's supposed to be a drum, and then my wife said that it looked like a bowl of rice. It's supposed to be a drum, and it's supposed to remind me that this is a drum roll. You may have already heard, but we also now support Firebase. So you can cause a function, a cloud function, to be invoked from a mutation in the Firebase real-time database, from lifecycle events on authentication, and also from analytics events from your mobile client. But I don't want to steal their thunder too much. They have a session today at 4 o'clock. I encourage you to go and have a look at that. And you can see here just those examples in the context of Firebase. So processing payments through an external provider, sending an email or an SMS, back-end service integration, so connecting to the rest of the cloud. And then funnel optimization is leveraging things like analytics to know what the end users are doing and to react to that with code. So a great example might be, depending on what the end user is doing, you might want to send them a push notification when they enter or exit a particular analytics cohort. So Cloud Functions is in beta today. It's available for everyone to use. Just go to that URL and you can find out more. That's all I have in terms of the content. Does anyone want to see a demo? Let me rephrase that. Does anyone want to see me try to do a demo and have it fail catastrophically and be embarrassed? Yeah, more people, great. Okay, switch to demo, please. Okay, this looks confusing. I'm zoomed out a little bit, that's why the boxes are a little bit. Let me see if I can make that a little bit better. Oh, that's worse. Okay, we'll live with it. Okay, what are you looking at here? All these grey boxes at the top, you can think of those as users calling your function. Now, unfortunately, when we were creating this demo, we thought it would be easy just to run it in a browser. It turns out the browser is not great at generating many, many concurrent HTTP requests. So even though there's, I think, about 80 boxes on the screen there, we're not talking 80 concurrent requests. They're just going to fire off requests as quickly as they can. Each little box represents a request. When the cloud function executes, it's just going to do one thing. It's just going to return a color. And the box is going to render the color that it returns. And that's it. Once we kick this off, we'll see these boxes switching color to whatever color the function is returning. It's returning the same color for everyone. Then I'm going to show you the deploy process. I'm going to redeploy a function. I'm going to change the color. And visually, you should see all these boxes flick over to the new color. And down below, what you'll see is the latency, the median response time from executing this function. So let's see if this works. Okay. These are all my boxes changing color. And below you can see the latency. Now, I'm going to switch over to my Cloud Console. Here's my send color function. I'm just going to edit. So you can see here, this is where I'm sending the response. It's just an HTTP function. I've got some cause stuff there just to make it callable from the browser. Just ignore that. So I'm going to change this to send green rather than blue. Hit save. And recalling what I mentioned before, that's going to send that deployment to the cloud. It's going to run npm install. It's going to build an image. It's going to create a version. I better switch across so you can see it. It's going to create a version. It's going to health check that version. And assuming the health check passes and everything's okay, that will become the current version. And right on cue, it's going to change. So that's just showing how easy it is to deploy a function, and if you had some error, some problem in it, the existing function keeps ticking, and we will health check everything, and then we'll switch across to the new version. And you'll notice that the colors didn't flick immediately. That's more a browser issue, but it may be that there's traffic that rather requests that are currently being served will complete before they get to the new version. So you might get some timing issue in that, and you saw that reflected there. Okay, so that's all I have today.